Prove that square root of 3 is irrational. Let us assume to the contrary that square root of 3 is rational, not irrational. Now let us assume it as rational. We know that rational numbers are those numbers which can be expressed in the form of a upon b, where a and b are integers and b is not equal to 0. Hence, we can write square root of 3 is equal to a upon b, where a and b are integers with no factor in common, means they are co-prime numbers. So we can write b root 3 is equal to a. Now we have b root 3 is equal to a. Now let us square on both sides like this and then rearrange. We can get square root of 3, the square is 3, b square is b square, a the square is a square. Now we can say that a square is divisible by 3. If we transpose 3 to this side, a square is divisible by 3, and by the theorem 1.3 it follows that a is also divisible by 3. So we can write a is equal to 3c for some integer c, substituting for a instead of a. Now we don't want this. Okay. Instead of a, we can write 3c. We get 3b square is equal to, instead of a, we have to write 3c the whole square. It implies that 3b square is equal to 3c the whole square. It implies not 3c, 9c it is. Okay. It implies that 3 ones are, 3 threes are. So b square is equal to 3c square. It implies that b square is divisible by 3 if we transpose 3 to this side. So b is also divisible by 3 by the theorem 1.3. Now you can observe that a is also divisible by 3 and b is also divisible by 3. And therefore a and b have at least 3 as common factor. But this contradicts the fact that a and b are co-prime. This contradiction has arisen because of our incorrect assumption that square root of 3 is rational. So we conclude that square root of 3 is irrational, hence proved.